Okay, so today we're going to continue with redox titrations. You've carried out your practical for this, so the redox titrations that we did on Monday, and now we're going to look at how we calculate the concentration of our unknown from that. So the whole purpose of this is the quantity of oxidizing or reducing agents present in a redox reaction can be calculated from the results of your titration. Now, they will always give you a balanced redox equation for this. They won't ask you to write it yourself, as with all your other calculations. And this really gives us the mole ratio for our reactants. And then we can use our triangle from National 5, so NCV, to calculate whatever the unknown is. Now, one thing to remember is that, let me just see if I can do this, our volume should be in litres. Okay, if they give it in centimetres cubed, we need to change it. So, first example is an example from National 5, really. We'll always have done this. Now, in National 5, you may have used the formula C1V1 over N1 equals C2V2 over N2. That will not always work at higher, so because of that, we're going to use a similar method to what we've done when doing our other calculations. So first step, always tick the two that you're being given some information about in the question. So in this example, it says what volume of hydrochloric acids, concentration 0.2 moles per litre, so we've got a number for that, let's tick it, is required to neutralise 100 centimetres cubed of sodium hydroxide solution, concentration 0.5 moles per litre. So that's sodium hydroxide, we're going to tick it. Now in this type of calculation, it will always be two reactants that we're looking at. Okay. Next step, as always, we do a mole ratio between these two compounds. So as you can see from the balanced equation, 1 mole reacts with 1 mole. After that, I'm going to use the information in the question. Now, there will always be one of your reactants that gives you two values for. Now, in this case, it's our sodium hydroxide. They've given us a volume and they've given us a concentration. So if we've got volume and concentration, we can use the NCV triangle to calculate number of moles. So we're going to do that just now. So concentration is 0.5. I have changed my volume into litres, remember, by dividing by 1,000. Now ignore my ridiculous handwriting, I'm just doing this with my laptop mouse, which is rubbish. Okay, so you divide by 1,000, you'll all remember. That's the main place people go wrong in this question, they forget to convert the volume to litres. So we carry out that calculation and we can see our number of moles is 0.05. Now it is a 1-to-1 mole ratio between them, so if we have 0.05 moles of sodium hydroxide, we will also have reacted with 0.05 moles of hydrochloric acid. This has now given us a second piece of information about hydrochloric acid. We know the concentration is 0.2. We now know the number of moles is 0.05. So I can use the NCV triangle again, but this time it's asking us to calculate what volume of hydrochloric acid. So we're going to do volume is equal to number of moles over concentration, which we now know our number of moles is 0.05. We know our concentration is 0.2 from the question up here, and it gives us an answer of 0.25 litres. Just remembering to put your units in, volume will always be in litres. Okay. Right, let's go on and we'll have a look at another example. If I were you, I would put an example of this into your jotter in your notes, just as we would in the class. And then we'll do a second example here. Then I've got plenty of examples that I want you to have a go at. Now, the answers are on the slides. The working is on the slides. So all you'll need to do is try it yourself and then go back and check it. What I'll also do is I'll attach some maybe links to past paper questions that I'd like you to try on this too, and you can see how you get on with them. It is important that you try this at home because we're really just treating this like a lesson that we would on an ordinary day. Okay, example 2. This is one that you're more likely to see in a higher paper, so not an acid-base reaction, but iron reacting with dichromate ions in an acidic solution. Now remember we talked about this the other day, as soon as you see H+ ions, then that tells us there's acid present. Anyway, that doesn't really matter for the calculation, but it's just to show you that that's there. So it's asking us to calculate the amount in moles of iron 2 ions, which will react completely with 300 centimetres cubed of dichromate solution concentration 0.3 moles per litre. So this question is actually more straightforward than the one we've just done. Let's have a look at it. So it's asking us to calculate the amount in moles of iron 2 ions. Now remember the 2 is telling us about the charge. Here you can see 2+, that's my iron 2 ions, so I'm going to tick this one. And it says which will react completely with 300 centimetres cubed of dichromate solution, concentration 0.3 moles per litre. So these are my dichromate ions. If you are unsure what a dichromate ion is, remember you have your group ions table in your data booklet. If they name an ion and you can't think what its formula is, check it there, that will help you. So we're going to do the mole ratio between these. So you can see we have, from the equation, 6 moles of iron 2 ions to every 1 mole of our dichromate ions. I'm now going to use my NCV triangle because I've got two pieces of information, 300 centimetres cubed and 0.3 moles per litre of dichromate that I can use to work out my number of moles. So concentration 0.3, and again volume must be changed into litres, divide by 1,000 and we get our volume. So it then gives us an answer, so 0.09 moles. Now it's a 6:1 ratio, so if 1 mole of dichromate ions has a number of moles of 0.09, I'm going to multiply that by 6 to get my number of moles of iron 2 ions, so 0.54. And that's your final answer. All it's asked for is the number of moles. That does sometimes happen. It would be worth less marks because you're obviously not then taking that number of moles and going on to the next one. So what I am going to leave you with now are some more examples. So example 3 here I want you to have a go at. When you go to the next slide, it gives you all the working and the answer. The slides after that are some taken from past papers, some just written from textbooks and things. I want you to have a go at those, see how you get on. If you have any questions, please just email me or comment on our Teams page. Okay, good luck, and I'll hopefully see you all soon. Bye.